Hello everyone, this is Mrs. Kulkarni, lecturer, Department of Physics, KLS Kokte PU College, Belgavi. In continuation with my earlier video, electric charges and fields, I am going to discuss the concept on axial line and equatorial line. So let us begin with axial line and equatorial line. Axial line. It is the line joining the centers of two charges of dipole and extended on either side. It is also known as end-on position. Equatorial line. It is the line passing through the center of the dipole and perpendicular to its length. It is also known as perpendicular bisector or broad-on position. So exactly what is the meaning of this? Suppose if we consider one dipole means having negative and positive charge. If the same dipole line, if it is extended, then this is called axial line. The line which is passing through the center of the dipole means again positive and negative charge, okay. If the line, imaginary line, if it is passing from the center of the dipole, then that line is called equatorial line. Expression for electric field at a point on the axis of the dipole. So this derivation is based on the axial line, which is very important for 5 marks. Consider the two charges, negative charge Q minus Q and positive charge plus Q. So this is an imaginary line. AB is a dipole. O is the midpoint of the dipole. 2A is the distance between A and B. C is a point on the same axis of the dipole, or this is a axial on the same axis. So C is a imaginary charge which is a positive charge. The magnitude or value is very negligible. So whenever we say consider a point means what? It is a positive, imaginary positive charge which is having very negligible value or magnitude. The distance from C to O is x. Then what will happen to the electric field from C to A? Means the electric field between this point C means positive charge and this negative charge. So this is positive, this is negative. So for that reason there is a attractive force. The direction of the force is in this way, as well as the direction of electric field from C to A is also same way. Okay, why it is like that? Because we already discussed in the previous videos that electric field lines properties. Okay, the field line always moving from positive terminal to negative terminal or positive terminal to infinity. So for that reason we have to show the direction in this way. Next, electric field E2 between B and C. So B is a positive charge here. Okay, C is imaginary positive charge. So always the electric field line is always moving from where? From positive to infinity or positive to negative. For that reason we have to show the direction of the electric field in this way. That is E2. And here force is repulsive because this is positive and this is also positive. P is a dipole moment, and we already discussed about the dipole moment, and dipole moment direction is always from negative charge to positive charge, from negative charge to positive charge. So for that reason this is the direction of the dipole moment. E is equal to E2 minus E1. So total electric field E is equal to E2 minus E1. So electric field is a vector quantity. Now these small a's indicates that they are the distance from O to A and O to B. The dipole total distance is 2A. this is total 2a, but when we consider the midpoint O, then this distance OA distance is a, OB distance is a, small a. Now AB is a dipole, that distance is 2a. OC distance is x. What is the distance from C to A? From this C to A is how much? This much it is x, and this much distance is how much it is? That is A. So OC plus OA, that is x plus A. Suppose if we take the square of that, then CA square is equal to x plus A bracket square. Similarly, BC distance, this BC distance is how much? So BC is equal to this OC minus OB, this OB. OC is how much? X it is, and OB distance is small a. So BC is equal to x minus a. Suppose if we take the square of that, then x minus a bracket square. So we understood the diagram properly. Now let us study in detail about that same derivation. Expression for electric field at a point on the same axis of the dipole. This is the actual derivation. Okay. So let us study step by step. Again same diagram. So minus q plus q, and P is a dipole moment, and that is the direction here. AB is a dipole, O is the midpoint, and AA means it is a splitted. The 2A distance is splitted. So OA distance is A, OB distance is also small a. Then C is a point on the same axis of AB or a dipole, that is imaginary charge, positive charge, which will not affect to the entire system. The magnitude is negligible. X is the distance from O to C. E1 is electric field from C to A, and E2 is the electric field between point B and C. So E is equal to E2 minus E1. Now consider minus q and plus q are the magnitudes of the charges of the dipole. 2a is the distance between the charges or dipole. C is the point on the axial line. X is the distance between point O and the point C. Now electric field C due to minus q. What is electric field? We already discussed in the previous videos. The space surrounded by the charge or the region surrounded by the charge is called electric field, and general expression for electric field is E is equal to 1 divided by 4 pi epsilon naught q divided by r square. So using the same formula here, electric field formula, E is equal to 1 divided by 4 pi epsilon naught is common. It is constant value. So instead of E, we have to consider E1, because two electric fields are there, E1 and E2. That is the reason. So we have to avoid the confusion, we have to consider one electric field between C and A, that is E1, and another electric field E2 is from B to C. So E1 is equal to 1 divided by 4 pi epsilon naught. Q is the charge. Okay. Then next Q divided by x plus A bracket square. Why it is x plus A bracket square? Already we discussed in the previous slide how we will get x plus A bracket square, because this is nothing but what? This is the A along CA. CA square is equal to x plus A bracket square. So instead of CA square, we have to substitute x plus A bracket square. And what is this A cap? A cap is a unit vector. Okay. So A cap is the unit vector which shows the direction of the electric field. Of course, the magnitude is negligible here. The value is 1. Okay. Unit vector value is 1. But It shows the direction of the electric field. That is the reason we have to mention A cap. Similarly, electric field at C due to positive charge Q means this charge. Then E2 is equal to 1 divided by 4 pi epsilon naught Q divided by, instead of BC square, so what we have to substitute? What is BC square? Already we discussed in the previous slide, that is x minus A bracket square. So substitute the value of BC square because it is along BC. Okay, so x minus A bracket square is nothing but what? BC square. Okay, how we got that BC square? Already it is there in the previous slide. And A cap means again it is a unit vector. Okay, now what will happen to the total electric field? So resultant electric field E is equal to E2 minus E1, where E2 is greater than E1. Substitute the values of E1 and E2 in the formula. In this formula we will get this answer. Okay. Next, final expression for electric field E is equal to approximately equal to 2p divided by 4 pi epsilon naught x cube. But how we got all these steps? Let us understand one by one. So E is equal to E2 minus E1, where E2 is greater than, because E2 is greater than E1. Okay. Now substitute the values of E1 and E2 or E2 and E1 in this formula. So what is E1 and E2? 1 divided by 4 pi epsilon naught Q divided by x minus A bracket square. This is E2 value. 1 divided by 4 pi epsilon naught Q divided by x plus A bracket square. This is E1 value. Substitute both the values of E1 and E2. Then next, what are common factors here? Q and 4 in the denominator 4 pi epsilon naught. So E is equal to Q divided by 4 pi epsilon naught factor is common. So take it out inside the bracket. What is remaining? 1 divided by x minus A bracket square minus 1 divided by x plus A bracket square. Next step, E is equal to Q divided by 4 pi epsilon naught. Take the LCM now. So this x plus A bracket square, it goes to numerator and this one also goes to numerator. So in the denominator multiply both the factors. So x plus A bracket square minus x plus A bracket square divided by x minus A bracket square into x plus A bracket square. Next step, E is equal to Q divided by 4 pi epsilon naught. Now you open the bracket, this x plus A. This x plus A is similar to A plus B bracket square. So instead of A plus B, here we are assuming x plus A bracket square. So x square plus A square plus 2xa. Similarly, x minus A bracket square is similar to what? A minus B bracket square. So according to that, x square plus A square minus 2xa. But here outside negative sign is there. For that reason, we have to multiply those values with this negative sign. So for that reason, minus x square minus A square plus 2xa. And in the denominator multiply both the factors, and finally what we will get here? X square minus A square bracket square. Now which quantities get cancels here? X square, A square, both these two get cancels because sign convention, positive and negative, x square and A square. Next step, E is equal to Q divided by 4 pi epsilon naught. Add both the values, 2xa plus 2xa means 4xa, and denominator value as it is. Next, E is equal to same 4xa. I split it in this way, 2x divided by 4 pi epsilon naught into 2aq divided by x square minus A square raised to 2. denominator as it is. E is equal to 1 divided by 4 pi epsilon naught, and this 2aq means what? 2aq, this value is nothing but what? Dipole moment P. What is dipole moment? We already discussed a dipole moment. It is a product of either charge and the distance. Okay, that is 2a. So 2a into q is a dipole moment. Instead of this value, we have to substitute in the next step p and 2x as it is. So total 2px and denominator as it is, that is x square minus a square raised to 2. E is equal to 1 divided by 4 pi epsilon naught 2xp divided by x square raised to 2. Then what will happen to this a square? A square is almost, it is negligible, because if we neglect, suppose if we neglect a, that is dipole distance, if we neglect this a, so if we consider almost it is negligible value, then what will happen here? So x square, only x square is remaining, x square raised to 2. So E is equal to 1 divided by 4 pi epsilon naught 2xp divided by x square raised to 2, where because a is very less than x. Next, E is equal to 1 divided by 4 pi epsilon naught 2p divided by x cube. Why? Because in the numerator 1x is there, and in the denominator it is total x raised to 4. Suppose if we cancel 1x from this denominator, then it will become x cube. So E is equal to 1 divided by 4 pi epsilon naught 2p divided by x cube. This is the final expression for the electric field for the axial line. So this derivation is very important for 5 marks. For further question and answers on first chapter, please go through the link given below. Thank you.